Ryan. Oh, CSL binder, but yet no head. For those of you guys just joining us today, because John said I couldn't see. Those of you guys just joining us today, I'm updating Google Classroom really quickly. I do have the FRQ packet, but I'll also get a scanned version for those of you guys that are gone. Because right now, I think all we have is a scanned version of the answer keys. And even that, this was only up until that last one, which was 2010. But I added the ones that went all the way up to 2016, and there were more. I just stopped. I'll get that scanned blank copy for those of you who are gone. You can print it off and be working on it. However, I added the comment that the evens are what is due on Monday, which is 2, 4, 6, 8, 10. And then the odds, which is 1, 3, 5, 7, 9, 11, are what is due the day of the test for up to +3 on the test. Sound good? Yeah.
Is it like you do one on, you get like something, or you have to do all?
For the bonus. Well, even for the evens. For the evens, I mean, I can give you partial credit based on what you do. For the odds, I can give you partial bonus based on what you do. But let's see, 1, 3, 5, 7, 9, 11. There are 6 of them, 3 points, so 1/2 point each. FRQ. Yeah. Okay, and that's percentage points on the test. Every now and then people don't realize that I mean percentage points on the test. Okay, that comment has been posted, so we have it. You guys have the answer key, but I'll get you the full answer key and the scan of the entire packet in case you lose it. But for right now, there we go. We have the multiple choice to go over questions on. We also have 10-4, 10-5 if you guys have questions on this one. I'm ready for questions, and as soon as you run out of questions, you guys just work and collaborate. So, is there anything multiple choice or 10-4, 10-5 homework that you guys want to go over? On multiple choice? Okay, let's start there, and I'm just going to keep on asking until there's no other answers. There are no other answers. Number 18. Remember, if you don't need this, go ahead and put it in your headphones and get some work done. But it might be helpful. Okay, number 18. If the tailor... Oh, isn't ln of x somebody I should know? Well, maybe not. This one's centered at x equals 1. It's kind of really nice that they gave it to me so I don't have to find it myself. So they give me the Taylor series. That's nice of them. It's right here if I plug in 1, plug in 2, plug in 3. They tell me that f is the function given by the sum of the first 3 non-zero terms. P.S. Do you guys see your decimals and see that there probably should be a calculator involved in the solving of this problem? If not, it would have been very sad trying to solve this problem. I want you guys to go ahead and have your calculator, have it ready. But can you also underline or highlight the maximum value of? Are they asking for an error bound? Are they asking for something this is bound by? Or are they asking for the highest it can actually go? Okay. I could say that this is bound by 100, and I'd be totally right. I could say this is bound by 50, I'd be totally right. I could say this is bound by 25, I'd be totally right. I think Lagrange tells me that it's bound by 7-ish if I plug in, and it's totally right. However, here's the crazy thing. The highest that this goes is a whole lot smaller than all of those. The highest this error goes is actually a whole lot smaller. Focus. Is actually a whole lot smaller. So how do I actually find the max value of? How do I actually find the max value of? Guys, can we actually find what this is? Yeah, how do we find what this is? Yeah, they told me what f of x is, and f of x is the first 3 terms. And so if I plug in the first 3 terms, I can actually put into my graphing calculator in y1 what this actually is. And I can make my x min be 0.3. I can make my x max be 1.7. And I can actually find the highest on my calculator looking at it and see how high it actually goes. This is not having me do crazy Lagrange or alternating series error bound. It's not about the bound. It's about literally, hey, find this and tell me what the highest is as you look at your calculator. So who is f of x? Well, doesn't f of x say plug in 1 and 2 and 3? And plugging in 1, I get a positive. Plugging in 1, I get x minus 1. all over 1 minus x minus 1 squared all over 2 plus, double check these, right? I think so, right? I did it fast. Plugging in 1, plugging in 2, plugging in 3. Set this equal to your y1, and let me give you a quick hint. Yes, this is your x min, your x max in your window. However, I would also make your y min kind of low, and your y max kind of low, because this doesn't go very high. And the way you would know that is if you were to plug into your calculator and go into your table and see what's going on at 0.3 and 1.7, or if you look at these values and see that they don't go very high. So make sure to have how low it goes, make sure to have how high it goes. And as you do, you will see that the highest actually occurs at 0.3, because this little guy, if I remember right, here's like your 0.3-ish, here's your 1.7, if you go ahead and set it up. Here's like your 0.5, here's like your negative 0.5. I think it starts off something like this, and it kind of like goes down, and then it goes back up. The highest it is right here. And so if that's it, then I go ahead and I plug in what's y1 of 0.3. It's the highest it is, and I get 0.145. I'm only telling you this because I did it yesterday afternoon. Did it? Is that you and me? I think it was you and me. Right? Plug in 0.3 and it's like, oh, dun, 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 dun. Oh, sorry. That's 0. It looks like a Lagrange question, but it's not. It looks like a Lagrange question, but it's not. But sadly, sorry, I totally just labeled that as 0 and it wasn't 0. This should have been moved over, and I don't think I can actually move it over. So let me move this over and say that this is 0.3, even though I didn't intend for it to be. But it was all in the wording, and I know that it's tricky because you're like, oh, I thought it was Lagrange. Now it's a random highlighter. Love that. Okay, good. There we go. Awkward, but they didn't say bound. They didn't even say error, even though it was error. And I'm sorry, I know that's nasty. I didn't like this question either, but the fact of the matter is they asked it. So the max value of, if you can find it, you graph it, you tell them exactly how high it goes, not what it's bound by, but how high it goes. And that was number 18, right? Yeah. Number 4 on the multiple choice? Okay, so number 4 on the multiple choice. Oh, it's way up here somewhere, sorry. Ooh. This one's tricky because they don't even tell you what the function is, right? If we have a series, a sub n, x to the n, Taylor series that converges to f for all real x, then f prime of 1. Well, you have a few different ways of doing it. One way is you could actually write it out if you really wanted to. You could do a sub 0, x to the 0, which is gone, and a sub 1, x to the 1, a sub 2, x squared, a sub 3, and then you can take the derivative, that's going to be gone. I have that, and then I have 2, a to the 2x, and then I have 3, a to the 3x squared. And then I could see which one works. I mean, that one is way too simple. That one is way more than that. Wait, ooh, I'm plugging in 1. Oh, wait, I'm plugging in 1. So that would be my f prime of x. This would be my f prime of x as a power series. So f prime of 1 says plug it in, plug it in. It should be a1 plus 2a2 plus 3a3. Which one seems to indicate the pattern that I see? The other way of doing it is you could have thought you were bringing down the n a sub n x to the n minus 1, but then that n, or sorry, that x to the, if I plug in a 1, that's always just going to be 1. So my x squared, my x cubed, all of those are 1. So I'm going to have n times a to the n, just by kind of taking the derivative and plugging in 1. And that's kind of what they showed me answer key. Like, take the derivative, bring it down, subtract 1, plug in 1. Yeah.
Can we do 5?
Yeah. integer k greater than 1 will both converge? Well, the very first thing I see is that this is a geo. Because if I was to write it out, n to the 1, n to the 2, it's this guy, and then this guy squared, and then cubed in 4th power. And remember, geo only converges if r is in between 1 and -1. So then I need k to be in between -4 and 4 in order for this one to work by geo series. And then if I need this one to work also, 1 over n diverges by himself. I have to have this be alternating. If I need this to be alternating, I can't have k be an even number, because if it's an even number, 2 times 1, 2 times 2, 2 times 3, those would be even pairings and would get rid of my alternator. I need it to be odd. So within here, I can't have k equals 0 or plus or minus 2. It has to be something else. And so, and it can't be a negative because, well, forget that. It says k greater than 1. So k could either be greater than 1. Man, k could either be 2 or 3. And if it can't be 2, then it must be. So I needed an odds to be alternating for that to converge, and I needed less than 1 in order. Anything else from the multiple choice packet or 10-4, 10-5 homework? 20?
I don't remember the number.
Yeah, let's see. This one.
Yeah.
Intersects the graph x cubed. Now, this one would be impossible if I needed to write out, because remember, just a second ago, didn't I tell you to put ln of x minus and then take the third degree Taylor polynomial and then plug it in your calculator? We could do that if there were only 3 terms. What's the problem about this guy? Infinitely many. It's impossible to put it in my calculator unless I can say what the sum of the infinite series is. Guys, who is this guy? Oh, it looks so much like e to the x. The only problem is e to the x. Hold on, isn't he positive everything? Add a negative. Wait, then everybody's negative. That doesn't work. I need the odd guys to be negative and the even guys to be positive. What if you plug in a negative x? Oops, if you square it, it's positive. If it's an odd power, it's negative. Who does this function sum to be? E to the negative x. And so I can go ahead and, Lorenzo, now it's as easy as graph x cubed, graph e to the negative x, and let's figure out where it intersects. Yeah. How do you put that in your calculator then? Alternators come in the form of -1 to the n. N is a summation. I'm trying to write it as a function so I can put it in my calculator. So I can't put an n. Well, no. I couldn't put an alternator in front of an e. Alternators are for my series notation because remember n's are whole numbers, right? And so I just go back between -1 and 1. If I was to plug it in with an x, remember x can be all real numbers, and then start having issues. Does that make sense? And remember, E is supposed to be the entire collection of all of that. It's not just this or this or this. It's the whole thing. Does that kind of make sense? You guys want me to pause and just you guys keep working? Let me know if you get stuck on something. That sound good? Okay. So if you guys want to move around the room, you can move around the room. If you want to stay, you can stay. If you want to get out Google Classroom and grade some stuff for a